My dear students, we have already learned about electron affinity and its concept, theoretical part, examples, questions, the factors affecting, and its experimental methods to find out the value. So, do you have a doubt that why we are studying electron affinity or any topic in chemistry? Why we study this topic? We have to understand the practical application or the use of that concept or that theory in everyday life. That's the reason why I have added this part also in my class, the significance and practical application of electron affinity. I have write down 5 significance and corresponding applications where they are using. The first and foremost application of electron affinity is chemical reactivity. Chemical reactivity, we all know that it is the amount of energy liberated or released when an atom at its neutral gaseous state accepts an electron, forming an anode. So, the tendency to accept more electron, which is very active, is electron affinity is very higher. So that's the reason why chlorine, halogens possess very high electron affinity and tendency to accept very less. If the electron affinity less means it has the tendency, it has not in a tendency to, it has a tendency to remove electron, right? That's the reason why the first and second block elements, the metals showing very low electron affinity. So the chemical reactivity, in other ways, which is the concept of charge transfer. Electrons are giving, electrons are acquiring. Okay, removing and taking. So this charge transfer reaction is very important principle in battery technology, in battery industries. For example, in lithium ion battery, the lithium ion, when we are plugging, the lithium ions are exchange the charges, that is the electrons are accepting. When we are removing, the electrons are giving to the lithium ions are liberating, means electrons are released. So that's the principle in lithium ion battery. Semiconductor field. In semiconductor, we all know that the metals are using, right? Germanium and transition metals are mainly used in semiconductor field. In semiconductor, if it has a tendency to accept an electron, it will be very less reactive to a semiconductor field, right? So almost all metals having the tendency to remove an electron. So in semiconductor industry, these charge transfer reactions are very important. So which is also following electron affinity principle. And chemical bond formation. We all know that the chemical bond formation, if the element or an atom is having a tendency to acquire an electron from another atom, there result an ionic bond, right? A formation of an ionic bond. So chemical bond formation. This one is already discussed, chemical bond formation. When an atom is having tendency to acquire an electron forming an A minus, then another atom, say M is having a tendency to give electron. So there is forming ionic bond. So chemical bond formation is according to electron affinity principle. And stability of an element. We all know that if the element is having half filled or fully filled electronic configuration or noble gas configuration, electron affinity value is 0, which means they are more stable. So stability can. The fourth and foremost one is metallic character and redox nature. The elements with a very high electron affinity value, which means it has a very high tendency to accept an electron, so which undergo reduction. So that's the reason why halogens are the best oxidizing agents in nature. Where we can take an example in everyday life, chlorine. The chlorination of fluor. We can use chlorine as one of the best oxidizing agents due to the higher value of electron affinity. That's the reason why in environmental chemistry, the principle of electron affinity is very useful. And why the metallic character? The electron affinity value is very low in the left hand side of the period. That means the group 1 and group 2. Group 1 metals, group 1 elements and group 2 elements. Group 2 elements having a fully filled s orbital. That's the reason why almost electron affinity is 0. So it has the nil tendency to accept an electron. So it is having tendency to give electron, right? It has a tendency to give electron. That means which undergo oxidation. So give electron. That's the reason why group 1 and group 2 elements are showing high metallic character. And from left to right, moving from left to right of a period, electron affinity increases, metallic character decreases. That's the reason group 1 and group 2 showing low electron affinity with a high metallic character. Halogens possess very high electron affinity with a low metallic character. Right? So this is the significance. And in environmental chemistry, the electron affinity value of chlorine halogens are very, very prominent because they are using in the pesticides, floor cleaners, and etc. Chemical harness. Chemical harness is a measure of a compound or a molecule or an element to undergo polarization, which means when an element is in a field, an element which is at its neutral state, when an element is placed in a field where a plenty of electrons are available, so whether it has a tendency to accept an electron or give electron. So this is measured, this measurement. So if the element get a negative charge, which means it's negatively polarized, right? Negatively charged. This is a measure of the hardness of that particular element. So chemical hardness can be determined by the principle by using electron affinity value. These are the significance of electron affinity, and we are using the electron affinity principle in battery technology, semiconductor method, catalysis. In developing a catalyst for a particular reaction, in order to control the electrons, the electron transfer, the charge transfer reactions, we are using catalyst. The catalyst must have the position, the catalyst must have the property to control the environment of the reaction. So catalysis and environmental chemistry as well as in electron capture mass spectrometry. We have already learned that in electron capture mass spectrometry, the ions are formed in mass spectrometry and analyzing it and at the principle of mass to charge ratio. Right? These ions are usually positive ions, but in electron capture mass spectrometry, anions are forming, anions are analyzed and chemically analyzed and determine the properties of that chemical element. So in electron mass spectrometry also we are using practical application of electron affinity, battery technology, semiconductor field, catalysis field, environmental chemistry, and 5 is electron capture mass spectrometry.